So the course that we're going to present over the next 3 days is really just a beginning or an introduction to cost estimation. And I will tell you a little bit about myself. Professor Lee started with an introduction. First, let me go over the outline for today a little bit. So the course is 3 days long. And each morning, we're going to have 4 hours of lecture. We'll go through all the basic estimating concepts. And each afternoon will be a workshop where you actually will be forming teams and preparing your own sample estimates. And one of my associates, Charles McGuire, he will lead you through your workshops in the afternoon. So the idea is to give you some of the theoretical information and then give you just a little hands-on practice so you get an idea of what we are doing. We also are here with Chloe Moon, who is also from our company, Strategic Estimating Systems. So if you need to ask a question in Korean, you can always ask Chloe, and then she'll tell me, what to do. Charles is a senior estimator with our company, Strategic Estimating Systems. All right, so this afternoon we'll have a workshop. Where are we? I'm jumping ahead. So just a little bit of an introduction, and hopefully you all have the books in front of you. I am Mike Monteith. I went to school for civil engineering at Columbia University. I was at Columbia at the same time President Obama was at Columbia, but I never saw him on campus, so I don't know. Theoretically, he went to Columbia University. Then I went and got an MBA at the University of Rochester and majored in finance. And right after that, I went into work into estimating. So I've never, even though I have an engineering degree, I've never worked a day of my life as an engineer. And it was at Columbia, we took some construction management courses, and I was first introduced to estimating. And almost instantly, I realized that this is what I'd like to do for my career, which was a big transition. I mean, how many of you, when you started college, knew what you wanted to do for your career? Did anyone? How many people now know what you want to do for a career? Anyone yet? For me, when I started college, I was 18 years old. I didn't even really know what an engineer did. The only reason I was in an engineering class was because my parents said, well, you're good at math, you should study engineering. And I was like, okay. And it wasn't until my senior year at college that I took some courses in construction management, and that's where I realized, hey, I really like this. I like estimating, and we also did scheduling. I say, I like this part of engineering, and started to focus on that as a career. Coming out of school, then I worked for Praxair, which is an industrial gases company, as a junior engineer in their estimating department. Then I worked for Linde AG, German company, as an estimating manager. After that, I worked for Fluor, who is a global engineering and construction company, and that was in Houston, Texas, as the estimating director. And then about 10 years ago, I started my own company, Strategic Estimating Systems. And the name Strategic Estimating Systems was selected on purpose. And the idea is that estimating as a function can be a strategic advantage to companies. So as you graduate and start to work, the whole world will change a little bit for you. Because in university, the goal is for you to learn. And when you start working, the goal is you have a company that's trying to survive. And the marketplace is very competitive. The marketplace is global now. And as soon as you start working as engineers, there's a good chance the company you work for will be competing on a global basis versus other Korean companies, versus American companies, European, Chinese companies. And it's very competitive. And the companies that stay in business are the companies that do the best. Whether they can do things faster or cheaper or better, but somehow you have to learn to be competitive. And my vision for estimating was that estimating can be part of a competitive advantage for these engineering companies. And traditionally, it's been looked at as just a discipline or something that has to get done. As you work through a project and build a plant, at some point you have to do an estimate. But the idea is that it can be considered something that if you get really good at it and really efficient, that you can use that for a competitive advantage. And so that was the whole idea behind our company, Strategic Estimating Systems. And that was about 10 years ago that we started. Just 2 more slides about our company, and it's important because it'll help you understand the frame of mind, frame of reference for what we're talking about over the next 3 days. So we are an estimating consulting company, meaning that's all that we do. We participate in all of the chemical process industries, oil and gas, refinery, LNG, mining projects, petrochemicals, power plants. And we specialize in the software that we're going to be looking at today. So for a lot of reasons, the Aspen Technology software for estimating is the state of the art. It's the best estimating software that's available on the market today. Now, maybe someone will come and produce a better software, but today it's by far the best software that's available in the marketplace. Best meaning it'll help you to prepare better estimates quicker and more accurately. So that's our actual expertise, and there's 3 main products. They have Process Economic Analyzer, In-Plant Cost Estimator, and Capital Cost Estimator. The product that we'll be using this afternoon and for these 3 days is Capital Cost Estimator, and you'll get your hands a little bit wet in that. We typically, when we train a new estimator, we plan that it's going to take at least a year till they're proficient using the software. And this is using it every day, 40 hours a week, because it's a very powerful software, but because it's so powerful, there's also a lot to learn within the software. But it's also very easy to start using. So pretty much by an hour or 2 into the examples, you'll be able to press some buttons and do some work in the software. Aspen Capital Cost Estimator. Lastly, sometimes we list the companies that we work for, but I like the nice colors on the slides. So these are some of our clients over the past 10 years. And you'll know some of the names you won't know. But certainly there's a good mix of Korean companies. SK is a client of ours, Samsung, Daewoo we do work for, and you'll see there's some companies all over the world. This itself should show you that really the marketplace is global. And that wasn't the case when I was in engineering school. And we didn't put the dates up there. Maybe I look young, I don't know. But it was 30 years ago that I was in engineering school. And so really at that point, the economy or the marketplace wasn't global. But today it's an inevitable fact, whether you like it or not. Some people like it, some people don't like it, but that's the reality. So if you're a mechanical engineer and you have a project and you have to buy a pump, it doesn't matter where your project is. That pump will be sourced anywhere in the world. You might buy it from Italy. You might buy it from Japan or China or Korea or the United States. And your project might be in Africa. I mean, pretty much everything is interchangeable parts, and it's a global economy. Even a company like ours, we're not a big company. We have 20 people, but we do work all over the world. And that's really the reality of today. So I know part of the whole idea behind this course and the other training courses is to really raise the competitiveness of you as students and the companies that you'll work for, because there is an investment that's being made in you with this material. So, I'm okay? All right. And certainly if you have any questions, please raise your hand. This is your time. This course is for you. So any questions you have, please stop me and we'll answer them right away. So what are the goals and objectives for the next 3 days? One is we just want to have a basic presentation of cost estimating concepts. So in 3 days' time, I want you to understand just in basic concepts, what is cost estimation? What do cost estimators do? We also want to provide an overview of the Aspen Tech estimating software as it relates to the overall cost estimating methodologies. We will explore some solutions to key estimating challenges. We're going to review the work processes that will assist in optimizing any company's cost estimating approach. And then we're going to explore some new tools and features to improve overall estimating accuracy. One of my goals is really to start training a new generation of estimators, because one of the characteristics of the engineering and construction industry, and estimating in specific, is that probably we're behind the times. So there's some industries that are really advanced. They tend to be cutting edge. And I would say our industry is probably lagging behind, where you have a lot of companies and people that are doing work the same way they've done it for 30 years, the same way they've done it for 20 years. And really, to me, we want to invest in some young, smart people and get your new ideas, because we need new ideas in this industry. But it's also a great opportunity for any of you that go into the engineering and construction industry, because if you can come in with some fresh and some new ideas, really you can help your companies and help yourself succeed. So that's a need in this industry. And so that's, for me, one of the goals and objectives. All right. So has anyone, I know you're students, has anyone had any type of internship or in any way been involved in a chemical project or an oil and gas project? Even if it's just the person that goes and gets coffee for everyone else. Has anyone ever been involved in that type of internship? Or? Okay. So just an overview of now, and don't feel bad. When I graduated, I couldn't even tell you what an engineer did. Isn't that strange? I had an engineering degree, and I didn't even know what an engineer did for their job. Now, hopefully your school is better, but basically our school was the professor would walk in, turn his back, and start deriving equations. And we just write every step, and then we would have to memorize the equations. None of us understood what he was doing. We could memorize it and put it back on a paper, but it was very impractical. And so it's hard to believe, but after 4 years of that, I graduated with a degree and did not even know what an engineer did. So we're hoping to address that today. So the real world, how do projects get built? A typical project in the chemical industry will take anywhere from 3 years to 8 years once it starts. And a lot of those projects take 5 years till they even get to the point of where they get started. There's all kinds of studies done. There's business people that look at it. There's evaluations of markets. So these are not fast-moving projects. This is, not Silicon Valley where you get an idea and then you implement it within a month. These projects have a long life cycle typically. And it makes sense, if you go to an S-oil refinery and they're going to do an expansion at their plant, they may have to invest, I want to get the yuan right, well, $3 billion or 3 trillion yuan, something like that. That's a lot of money. And for them to make that investment, they have to really be sure that it's a good investment. So typically a normal project will be studied for some amount of years before it even gets started. And when finally the management agrees, okay, this is something we should do, you go into research and development. And right away, now what is going to be the best process? What's going to be the right chemistry and the best solution to have a profitable project? At this point, already, you have to do estimates. And we'll talk about the different classes of estimates. But at every place along the way, you go research development and you move down the timeline, you're doing evaluations and estimates because you always have to be checking, is this going to be profitable? You know, the time for just a good idea, there's a lot of good ideas, but there's not a lot of good ideas that are profitable. Right? You can put a man on the moon, but is it worth your investment, right, to spend trillions of dollars to send someone to the moon? So there's a lot that's possible, and there's a lot that you can do. But in the business world, you always have to be asking, is there a return? At the end of the day, is this going to make our company successful and make us profitable? The next phase, once you decide, you select the process, you go into conceptual engineering, and you just do some basic chemical or process design, and you might pick a location at that point. Just say, okay, we're going to put this plant in this city or in this country. And again, at this point, an estimate will be prepared, checking the budgets. The next is what we call basic engineering. And the main goal of basic engineering is to finalize your process design. So process, again, it's still the chemistry, but you want to finalize that. And then you start to do some of the site-specific engineering, but it's just a start. This is what we call the conceptual and basic engineering, FEED, FEED. That's front-end engineering and design. In a total project, by the time you get here, you've probably expended about 15 to 20% of your total engineering hours. But right here, this is the point where a company will make a final decision and say, are we really going to make this full investment now? Because up to here, let's say you have a $1 billion project. At this point, you've probably only spent, $30 to $50 million, which it sounds like a lot, but it's only 3 to 5% of all your money. And so up until here, companies are still saying, okay, we'll look at it, it looks good. But typically then at this point, they make the final investment decision and say, yes, we're going to go and build this project. This is the most important estimate that you prepare. We call it either an authorization estimate or a plus or minus 10% estimate. And then if the answer is yes, we're going forward, then we do most of all the rest of the engineering, detailed engineering, and then we construct the plant. That's a typical project. For a large chemical plant or refinery, this process from here till you have a constructed plant is 5 or 6 years. On small projects, it can be 1 or 2 years. It's not months. So, just a little different way to look at it. The project work process diagram. So this is just a little different way to look at what I was talking about. And the idea is, central to all of this is the process design. So that's the core of any chemical plant, any refinery project. The core is your process design. And it's just showing here that at different phases of the project progression, you still will have economic analysis or estimates that are done at each phase. Key to all of this, now some real world stuff comes in. Even if the chemistry works, it has to be able to be done safely, and you have to be able to operate as well. So this is where the practical nature comes in. Because you can work some really good chemistry, but you might not be able to make it work from a practical standpoint or in a way that is safe for everyone. Another way we like to look at this is if we start with our main investment, these are all different ways to look at the same project progress, moving through the life cycle of the plan. So typical cost estimation accuracy. We start now at the investment decision. Now this is the same project work process, but just showing some different information. Typically here we'll have what's called a study estimate. And we'll talk a lot about the range of accuracy. You could do an estimate at any level of a project, but the accuracy you can have is very different depending how defined that project is. When you're very early in a project, there's so many unknowns that your accuracy range might be plus or minus 50%, or even plus or minus 100%. Meaning, if you think a project is $1 billion early, the range might be as much as plus 1 billion, because there's so many unknowns early in a project. As we move through a project progression, now FEL is another acronym. We love acronyms in our industry. So sometimes we start projects, and the first thing we're handed is a dictionary of acronyms that will apply to that project. Pages and pages of acronyms. So FEL stands for front-end loading. Front-end loading. ConocoPhillips developed the FEL process, but now a lot of companies have adopted that over the years. And each place where we get to a gate, the gate really means there's a decision that senior management will make. Is the project going to keep going forward? You do a certain amount of work, you evaluate, you decide, is the project going to go forward? A typical project goes through 3 or 4 gates until it's finally built and constructed. FEL1. At this point, we'll do an accuracy level of plus or minus 30% estimate. FEL2, plus or minus 20%. FEL3, plus or minus 10%. FEL4 is where you construct the project. Another feature as you go into industry is certainly different than some other industries is the projects that you work on. There's a lot of outside forces that, because they're so big and they're so strategic, can affect, again, if your project gets approved or if it's successful or not. You know, certainly if you read the news or watch the news, oil has all kinds of political ramifications. What does it cost for oil? What does gasoline cost? So, you know, right now we're working with a client that is proposing a massive project in Mozambique. And they've been working on this for years. Everything looks good for this project, except one problem. There's a civil war about to happen. Right? And you'll find that in this industry that even geopolitical decisions or forces can affect your projects. They also affect your estimate, right? We've been in situations where we have to put in an extra 10% on an estimate just for security. Right? Some of the oil projects in southern Nigeria have a lot of problems with, for whatever reasons, you know, that people try to blow up pipelines. Right? I mean, these things are strategic, and they're so valuable that there's a lot of other forces that come in besides just the math or just what you're working on. So, as you're going through that, I say that to say, plus or minus 10% is actually a very accurate estimate. And we're going to talk more about this. As engineers, if you're going to be an engineer and you're designing a structure, I want you to do better than plus or minus 10%. So if you're going to design a bridge that me and Charlie are going to drive over, I want it to be exact. And you can do that in engineering. But something like estimating, there's so many forces and so many variables that nothing is exact. As much as you're disciplined and use good procedures and good practices, you can never know for sure what's actually going to happen. Right? So there's a lot of other forces at play here. Typical project, typical progression. Certainly this is the point, what we call FEL4. That's when the project is completed. And then you go into operation. Okay. So let me just shift focus a little here and talk a little bit about what it takes to be a good estimator. If my company was here and we wanted to hire some of you for our company, what would we be looking for? What makes an estimator a good estimator? Probably the most important skill for an estimator is to be curious or to be a continuous learner. So this will apply as you go out to your careers. You never want to stop learning. You always want to keep advancing yourself. You want to learn more, do more, get better. But the skills for estimating there's hard science that you need to know for sure, but there's also soft skills that are maybe just as important or maybe more important. So your estimating skills, you always want to be developing that. You want to be getting better. You want to be working on that. Your industry knowledge. So you heard me talk a little bit about some examples in Mozambique or different projects. It's important that you understand industry. You understand what's going on. Is it a location that is very busy? Is it a location where there's a lot of active work? Or is it a place that's dead? Are there workers available? That's an issue sometimes. Someone proposes a project, but there's not even workers available. So you can always convince people to come work on your project, but if you pay them enough. So all of a sudden, okay, we can build a project in the center of Algeria, but guess what? It's very expensive to get someone to go work in the center of Algeria. Eventually, you can pay them enough money to say, yes, we'll go work there. But whereas where I'm from in Houston, there's a lot of people that live there and in the industry, so it's very easy. If you have a new project, it's very easy to get the resources, whether it's engineers or construction workers, to build that project. So you need to understand what's going on in the industry. Certainly, you need to understand at a high level processes. So you're not, to be an estimator, you do not have to be a chemical engineer and understand the thermodynamics of a certain process. But you do need to understand a little bit of, well, if I start with gasoline, I can make ethylene, and out of there we can make plastic. You do need to have some cursory knowledge so you kind of understand how the pieces fit together. Professionalism. Bless you. This will be in anything you do. But how do you carry yourself? Are you professional? Can you imagine, you're an estimator and someone's counting on you for a decision that may make their company or may make them go out of business. You're responsible for an estimate that, if it's wrong, can ruin a company. So certainly for managers and for everyone that you're involved with, owners and clients, you want to always be professional. You want to treat the job with the respect that it requires. Communication, this is number one, by far number one. So I will stay at this point for a little bit, is you have to be a good communicator. So if you want to be an estimator, you need to not be the person that just wants to sit at your desk all day and hit keys and have formulas go and run numbers. The most important skill for an estimator is to be a good communicator and to be a willing communicator. So typically when we get on projects, we will find that the estimator tends to be the only person that talks to everyone on the project. And so you'll have an electrical engineer, and all they want to do is think about electrical and do what they do. You have people that just design pipe, and they want to only focus on their piece. And you have the process engineers and civil engineers. Someone has to make sure everyone's communicating with one another. And just because of what an estimator does, that they can be that key person that brings communication and help to make your project successful. And what you want to keep in mind is, you know, some of our junior estimators, they'll make a mistake and think that their goal is just to do an estimate. And that's not really the full goal. That's only a part of what they need to do. But really their goal is to have a successful project. And the estimate's just one piece of that. So you want to be a good communicator. And also you have to be able to build confidence. So as you present your work, you will always have to present your work. And you want to be able to present it confidently and show that you've been very competent, that you've done a good job. So no one will expect you to be perfect, but you still have to be able to present your work properly and to be able to communicate that. And then the learning, we say, is step-by-step, on-the-job training. So the day that you graduate and go to work somewhere, you start with a blank sheet of paper. And you will find as you go through your career that what you've learned in school will help you a lot. But your actual job, it's a day-by-day. You learn step-by-step. And every job you should be trying to learn something new and trying to get better at doing that. So certainly for an estimator, this is critical. So that's the individual, what it takes. Then what are the key components of preparing the estimate? The very first thing is to plan your work. So I'm going to talk a little bit, I'm going to put that to the side because a little bit later I'm going to talk about that in more detail. But plan your work. You have to prepare. So in college, probably none of you, but when I was in college, I was just a classic procrastinator. There were so many fun things to do, go do things with my friends. So I'd always put the big assignment off. There's always tomorrow to do the project. And then you stay up all night before it's due and get it completed. That's okay in college. But in the professional world, you can't do that because there's no way to catch up. You have to be diligent and stay on top of your work and really stay caught up with your work because it accelerates. Everything goes faster and faster and more information. So you want to make sure you prepare and stay organized. Now I'm going to stay over here. Now this will not apply to you, but sometimes we hire some people and they're a little bit lazy. So sometimes you have to remind them, well, you just have to do your work. Stop going on YouTube all day or Facebook all day and actually sit at your desk and do your work. But that's none of you, I'm sure. I talked about communication too. And then meet your commitments. This is critical. Once you're on a project team, so an estimator will always be part of a project team, and you always have to meet your commitments. You owe it to your team members to say, if I'm going to have the first part done in a week, that you complete it in a week. But you can also expect them that they need to meet their commitments as well. And when I'm on a good project, that's what you see. There's a team environment where everyone does their part and stays on schedule and meets their commitments. I've had times where, and this can be a good learning for you, when I was a junior estimator, sometimes you have bad news. Either you make a mistake or you do something properly, but the numbers look really bad, and it's bad news. And my first thought would be, well, I don't want to tell the project manager because he's going to get upset or she's going to get upset. And I learned that that's the worst thing, is even if you have bad news, you need to communicate that right away. The sooner you communicate that, then everyone has a chance to react and everyone has a chance to maybe make a change and solve a problem. So even with your commitments, that's another reason it's important to be on time, because it's not, again, it's not just you getting your estimate done, it's you're part of a project that's trying to get a lot of work done and have a successful project. And then, of course, we talked about communication. You have to be able to present your results. Okay, last slide, and then we're just going to take a 5 or 10-minute break here. The last, as far as keys to successful estimating. So I touched on it a little bit, but I want you to, in your mind, understand that it's not engineering. Even though you're engineers, it's a really different way that you have to think as an estimator. Is it science or is it art? And unlike a hard science, there's a lot that you will do as an estimator that is a judgment decision. If someone asked me, how many hours does it take a construction worker to weld a 6-inch pipe? There's no set answer for that. It might take one worker 3 hours. It might take another worker 4 hours. It might take the worker 4 hours, 8 hours, if the night before he had a fight with his wife, right? There's so many variables, and there's so many judgments that you have to make that there is some science behind it. Believe me, there's a lot of science and there's a lot of data that you can use, but it's also just as much art or experience or judgment decisions to prepare a good estimate. And it's completely different. We all the time, every day as we work with engineers, we have to work with them and help them understand that they may want something to be perfect, but I have an estimate due in 2 days, and it's going to take them 8 weeks to get it perfect. So today, good enough is okay, right? But that's not how an engineer thinks. So there's this balance of making the good decisions, staying with your schedule, understanding there's a time to make a judgment call, and understanding there is a time also where you want to be based on hard fact. But really, it's a completely different mindset. There's a lot of similar skill sets, but it's a different mindset than doing hard engineering. And that's what we're saying here. It's part subjective and part objective. Very different from engineering and hard science. It's a different thought process, different approach. What are some of the reasons? I talked about worker productivity. A lot of times a design isn't even completed. So when we prepare a full authorization estimate, what did I say? Engineering is only 15 or 20% complete. That means you have to figure out what's that other 80% of engineering going to look like. But you have to do the work now, even though the engineering is going to proceed over the next 18 months maybe. Market conditions. You can go to the same person to buy a pump, and if they're really busy and they have a lot of work, they may tell you this pump is $10,000. 6 months later, you can talk to that same person, and now they don't have any work, and they're just trying to stay in business. They may sell you that pump for $2,000, and it's that dramatic. So again, that's not hard science. You have no idea. Well, you have some idea, but you're not sure where is that person or that company in their own internal process of what they will sell that pump for. Predicting uncertain outcomes. Here it is, our definition. Cost estimating is the predictive process used to quantify cost, and price the resources required by the scope of an investment option, activity, or project. It's a process, and this is the key. It's used to predict uncertain future costs. So now I know you may not think about these things, but I think about how much gas costs because I buy gas, and also it affects our company. But in September, do you think there's anyone was predicting that the price of oil would be cut in half in a matter of months? I mean, I didn't hear anyone, and I'm in the industry every day. And depending where you are, oil was roughly $100 a barrel. And now here we are in January. That was October 2014. And now here we are in January 2015, and it's $50 a barrel or $45 a barrel. No one predicted that. There's no way to know for sure. If you're in October and you're doing your estimate, you're not sure what's going to happen in 3 months, much less 5 years from now. Because imagine some of these projects take 5 years to build, and you're trying to cost and estimate work that's not going to happen for 4 years. So hopefully you're getting the big picture that there's a lot of art involved, a lot of experience. And more than a lot of, when I was a younger estimator, I didn't understand this as well. And I really thought if I could sit at my desk, I can do the right things and come up with good numbers. And then I would work for 3 months, and I would go into a meeting and present my results, and there'd be some senior manager that I've been working on it 3 months, and he's been looking at this for 5 minutes. And he says, "Oh no, that's wrong. This needs to be higher." And I used to get mad about that. Like, what? How does he know? I'm the one that's been working on this. But I learned to realize that his experience maybe is much more valuable than all this work I've done. And there's a reason why he's saying that. So then, as I've gotten older, I listen more. So when someone says that now to me, I say, okay, I better go check that because this person has a lot of experience. Now, it doesn't mean they're always right, but it means there's more to this than just the work. That's the point I'm trying to make, is that people's judgment matters a lot. So any questions? Yes?
You emphasized about keys to successful, but what I want to know is that your biggest failure, or could you be more specific about your mistake that you fought, if you don't mind?
Yeah, I don't mind. That's a very good question. So what are some of the biggest failures or biggest mistakes? And I can give you a couple at different phases of my career so you can get a range. One of the first big mistakes I made was when this is the very first estimating job, is I was given an assignment and had all these engineering drawings I was working with. Back then it was paper, no computers. And it was about a 2-month assignment. And I got into the details and I was working and figuring out quantities and prices. And somewhere, I didn't realize it, but somewhere along the way, I started to get off track, and no longer was I answering the question that I was supposed to be answering. So after 2 months of work, I bring in and present my work, and everyone says, "That's great, Mike, but that's not what we asked you." I'm like, "Oh, I guess you're right." So what I learned then is, at least for a while, till I always remembered that, is when I was given an assignment, I would write it down very briefly and put it in my cubicle right in front of my face. So every day I'd working, "Oh yeah, I'm working on the right thing." And I'd be working, "Oh yeah, I'm working on the right thing." It sounds silly, but when you get in a big company, there's so much happening, it's possible to even lose track of what you're doing. So that was a good learning. Next, next big learning is, as you progressed in my career, was just what I was talking about. Was then I got better at estimating, but I would work, if I had 2 months to do an estimate, I'd work up to 1 day before 2 months and then just say, here you go, here's your estimate. Now in this case, it might be better, but I've lost the value of having review with the people that have more experience. So again, I learned that it's just what I was saying, you can't leave that assignment till the last day. But I realized if I have 2 months to do an estimate, it's better to do as much as I can for 1 month and then start taking it and reviewing it with all different people and get their input. And that you have to realize that there's a lot of people that know information that you don't know. And so you had to start communicating with them. Third, and this is probably most important, is as an estimator, there's always pressure to do your work quickly and to do it as accurately as possible, because the decisions that will come out of the work you're doing are very important. So a lot of business people, a lot of managers, they want you to do your work quickly and accurately. But you have to learn that you can't just please that person. Because if you're trying to do something quicker than it's possible, or you don't have the right information, you might give them a bad answer. So I've learned that you have to be able to say, no, I need a little more time to do this properly. And again, when I was more junior, I just wanted to please my manager, and I would do the best number I could. I thought I was doing a good job, but then in the long run, it doesn't work out well. So you have to be able to say, no, I need a little more information. The process isn't finished yet. I need the engineers to give me some more information. Or the design isn't at a place where we can do the estimate yet. Because you might, in the short term, you might think, oh, this is good. I got this assignment done, and I made my manager happy. But in the long term, no one will be happy because they'll have bad numbers. So, but that takes a little, as a junior estimator, you just got to do what you're told. But that's more, as you become more of a leader, you have to be able to say, listen, we need to get a little more information, and let's slow down, everyone, before we rush and make a bad decision. So, yes.
I just wonder about the company like SES. So I believe that there are several big companies, but I think they have their own estimators inside. Probably they can be the more expert or more experienced, because they can be accessible into their system more easily. But probably they also want to ask you to estimate about their process, and what is the big difference of your company compared to other estimate team inside your client?
It's a very good point. So pretty much every engineering and construction company will have their own estimating department. So we work with Samsung, but they have their own estimating department. SK has their own estimating department. But we also, pretty much most of the people in our company worked for other companies first. So they've been part of estimating departments. The reason that companies will use our service is, first of all, sometimes they get too busy. So if you can imagine, SK has, their normal workload is 4 estimates. And now all of a sudden they get asked to do 8 estimates. But it's only for 2 months. They don't want to go out and hire 20 more people just for 2 months. So they would use our service, we call it peak shave, just for an extra busy time. They would say, hey, can you guys come in and just help us with one? And the other way that we provide a service is on this software that we're going to be teaching you, we're experts, global experts. So a lot of these companies are busy doing their work every day, which is good, but they need a little extra training or extra teaching on the software so that they can raise their levels internally. So it's kind of those two ways that we get used. So. But it's a niche. See, what we do, we're consultants, so we have 20 people. We're never going to be a 1,000-person company. Right? It's just a niche, and we provide a service to the bigger companies. I mean, Samsung themselves probably has hundreds of estimators. One company, Fluor, where I used to work, we had 200 estimators. So, good question, though. Anything else? So let's just take a 10-minute break, and we'll get started at 22.